Today we are going to be talking about solving systems of equations using inverse matrices. By the end of this video, you should be able to solve a 2x2 system of equations using inverse matrices. First, we need to talk about matrix equations. A matrix equation will look something like this. Here we have a 2x2 matrix that will contain numbers times the column matrix xy equals another column matrix that will have numbers in it. This is a matrix equation. So to simplify it, I'm going to write this as A times x equals B, where this first matrix is matrix A, our last matrix is matrix B, and the matrix with x and y is going to be x. Before I show you how to solve this matrix equation, let's go back to Algebra 1 real quick. If we have the equation 3x equals 6, we typically divide both sides by 3. But the other way we can do this is by multiplying by the inverse of 3, which is 1/3. If we do that, we end up with x equals 2. So that's the same thing that we're going to do with matrices. But the important thing to remember about matrix multiplication is that in general it is not commutative. A times B is not necessarily the same as B times A. So when we go to solve this matrix equation, A times x equals B, we are going to multiply by A inverse on the left. A inverse times A will give us the identity matrix. So we have Ix equals A inverse B, and the identity matrix times x is just x equals A inverse times B. So in general, we are going to left multiply by A inverse, and that will solve the matrix equation for us. So let's look at an example. If we have this system of equations, x plus 4y equals 14, and 3x minus 2y equals 0. In Algebra 1, you learned 3 ways of solving this system: substitution, elimination, and graphing. Now I'm going to add another method to your toolbox of ways to solve systems of equations, and that is using matrices. So, if we want to write this system as a matrix equation, first you need to make sure that everything is in standard form. You have the x term first, then the y term equals the constant. Then you want to look at the coefficients. We have 1x plus 4y and 3x minus 2y. So I'm going to write my matrix as 1, 4, 3, -2, because we had 1x plus 4y, 3x minus 2y. Then our second matrix is our variable matrix. So we have x and y equals the constants on the other side of the equal sign. 14 and 0. This is our matrix equation. Then we're going to do, as I described earlier, if this is matrix A, matrix X, and matrix B, we need to find the inverse of matrix A so that we can left multiply by A inverse. So off to the side here, I'm going to go ahead and find A inverse. Remember that to find the inverse of a 2 by 2 matrix, you have 1 over the determinant. To find the determinant, you multiply these two and subtract the product of these two. So you have -2 minus 12, which is -14. Then you rearrange your matrix a little bit. You switch A and D, so I'm going to switch -2 and 1, and then you negate B and C, so -4 and -3. I'm going to go ahead and distribute my scalar, so I end up with 1/7, 2/7, 3/14, and -1/14. And this is going to be A inverse. Now I'm going to write this problem out a little bit longer than I would expect you to write. I am going to go ahead and left multiply by A inverse. Then remember how to multiply matrices. Since we have A inverse times A on the left side of our equation, that should end up with the identity matrix, but we're going to go ahead and multiply it out so we can double check our work. Remember, you multiply the first row times the first column, and that's going to give you the value that is in the first row, first column. So we do 1/7 times 1, which is 1/7, plus 2/7 times 3, which is 6/7. 1/7 plus 6/7 is 1. Then we multiply the first row times the second column. 1/7 times 4 is 4/7, plus 2/7 times -2, which is -4/7, so that gives us 0. Then we multiply the second row times the first column. 3/14 times 1 is 3/14, plus -1/14 times 3 is -3/14, so that gives us 0. Then we multiply the second row times the second column. 3/14 times 4 is 12/14. -1/14 times -2 is +2/14, so that gives us 1. That is the identity matrix. The principal diagonal, the one going from the top left to the bottom right, is all 1s, and everything else in the matrix is 0s. Then we need to multiply on the right side of the equal sign. First row times the column. So we have 1/7 times 14 is 2, plus 0 is just 2. And then multiply the second row times the column. 3/14 times 14 is 3, plus -1/14 times 0 is 0, so that's just 3. So the identity matrix times x, y, you can either multiply those together, or since it's the identity matrix, you know that you are going to get x, y equals 2, 3. So this tells us that x will be 2 and y will be 3. and that will be the solution to our system. You can check it by substitution, elimination, or graphing if you don't believe me. Let's go ahead and graph this so I can show you how to check your work. If you go to Desmos or you use your graphing calculator and graph these equations and look for the intersection point, it gives you 2, 3, which is the same answer that we got using matrices.